Welcome to 56-Bit Cloud Cafe, your go-to destination for all tech topics in the cloud. I'm Atir Zalat.
And I'm Patrick Camilleri. And together we'll be addressing various cloud topics.
Hello everyone and welcome back to our podcast series. In our previous episode, we introduced SQS and discussed its importance in cloud architecture. Today, we are taking a deeper dive into the practical aspects of SQS. Whether you are new to SQS or looking to optimize your current setup, this episode is packed with valuable information for you. So let's start. As we said, today we are going to get more technical. To start, could you walk us through how to set up and configure SQS?
Right, thank you Atir for the questions. Setting up and configuring SQS is a very straightforward process. This is a serverless service, so there is absolutely no infrastructure to manage. You just use the management console of AWS, or you can use the programmatic level like CLI, so you can use SDKs, or you can use infrastructure as code like CloudFormation or Terraform. Whatever you use though, whether it's through code or through the management console, through a UI, you simply define a queue name and configure some attributes like message visibility timeout, for example, which means how long the message remains in the queue whenever someone reads that message. Or dead letter queue behavior. So if a message is not read or is read multiple times but never deleted, then it becomes a dead letter, a dead message. What happens then? It can be either discarded or it can be sent to a dead letter queue so that you can then check it out manually. So anyways, these are attributes available when setting up the queue. Of course, these can also be changed later. Some of them or most of them can be changed later as well. But it's a very simple process to get started.
Okay, perfect. Thanks for that overview. Now, I've heard there are different types of SQS queues. Can you explain what these are and when you might use each type?
So, Simple Queue Service offers two main types of queues. Originally, it offered one, which were the standard queues. Then they introduced the FIFO queues, the first in, first out queues. So the standard queues are the original ones. They allow, probably you can use them in most use cases, and it allows asynchronous message delivery, which means you're sending something to the queue and then you can retrieve it later. There is a buffer in the middle, a buffer of time. In fact, we call this a transient store because there is a buffer of time there that allows it to be stored for a little while, up to 48 hours if I'm not mistaken, and that allows the receiving application to process it later. And the standard queues, they guarantee that they will be delivered at least once. So if they are asked for the message, if an application asks for the message, it will be delivered at least once. You can configure things like visibility timeouts, for example, which we've mentioned before. That's how long a message is considered in progress before it becomes dead. Then there are FIFO queues. FIFO queues, first in, first out, they guarantee strict message ordering. So the first one that comes in is the first one that goes out. They guarantee that, and that ensures that messages are received in the exact sequence that they were sent. There are certain situations where this is crucial, like financial transactions. Spending 10 euros on something and then adding 50 euros to your bank account is very different from adding 50 euros and then spending 10, right? They are two different things because financially that makes it a big difference, and that would require the FIFO queuing.
Amazing, that was really helpful. Now let's get into the nitty-gritty of message handling. How does SQS actually handle message delivery and processing?
Yeah, so when a message is sent, SQS makes it available for any authorized application to receive it. So any application that has the ability to receive a message, it can receive that message. That ability is obviously controlled through permissions that you set through IAM. The application that is receiving the message will initiate the connection, will tell SQS, will pull SQS and tell it, can you give me a message please? And this keeps going on a loop. Can you please give me a message? Can you please give me a message? Can you please give me a message? Eventually, SQS will have a message to give it. So the application controls when and for how many times it asks for a new message, and SQS will deliver that message if it has one. This is known as short polling. This continuous checking can be suitable, especially for real-time processing, but it can be quite inefficient in terms whenever you have low message volume, don't have a lot of messages. Then there is the other option, which is long polling. In this case, the application receiving the message will ask SQS, will ask, can you give me a message please? And it will wait. It will wait a few seconds. This is configurable up to 20 seconds. It will leave the connection open. And when SQS has something, it will send through that open connection. That's when the connection will stop, will be disconnected, and then obviously the application has to ask again. But that makes it a lot more optimized, because up to 20 seconds you have the option of receiving a message. You don't have to ask all the time. There are other important features as well, like visibility timeouts to prevent applications from holding onto messages indefinitely, right? So an application will receive a message, and if it doesn't process it within that visibility timeout, within those seconds, minutes, or hours, then SQS will make it available again, that message, for the next application to process it.
Now, before we wrap up this episode, let's talk about costs. What are the pricing models for SQS, and how might this impact a company's decision to use it?
SQS is very cost effective because it is serverless. It's serverless, meaning that there is no management costs. You don't have to manage anything. That has a cost to it when managing servers, so that's important to take into consideration. But also, it allows you to send and receive messages, and you pay for each message sent and received. So for example, if you don't have any messages to send or receive, you will not pay anything, right? It's a pay-per-use pricing model. Now, the charging is done on two factors. There is the number of requests made. So here, every API call where you send or receive or delete a message incurs a small cost. Of course, if you have millions, then that will start adding up. But this is extremely small, the cost per API call. And then there is the data transfer element. So the amount of data transferred into and out of SQS is also charged per byte, to the nearest byte. So requests and data transfers, that's how SQS bills its pay-per-use model. As most services in AWS, there are also free tiers for both the requests and the data transfers. So for low volumes, for small applications, it might actually be even more cost-effective than that. It might even be free.
That concludes our deep dive into Amazon SQS. Thanks for tuning in, and we will see you in the next episode where we will explore the advanced SQS concepts and integrations. Until next time, happy cloud computing!
If you have questions, suggestions, or want to share your feedback, connect with us on social media.
Also, don't forget to subscribe to our podcast and to leave us a review to help others find their way to the Cloud Cafe.